3, 2, 1.
Hit it. Experience 24 hours of head-to-head AWS sessions from around the world.
Mic check, 1, 2.
Jaws PANKRATION 2021. Up till down.
Please start to speak. Tadaima.
I think my Zoom just crashed.
Go ahead.
Okay. Sorry about that. Okay. Infrastructure as code lets you automate deployments of your infrastructure to facilitate both scaling and quicker repeatable deployments. It's also code. And this means that you can version control it, code review it, test it, and push it through the different stages of a CI/CD pipeline. But when something goes wrong, it has a much wider blast radius. It might work on your machine, and maybe it even works in your account or in one region. But when it goes wrong, more resources, more regions, more customers, more dollars are impacted. It's no longer isolated to just one machine, account, region, or customer. We know the cloud makes it easier to provision infrastructure, but there's complexity with that scale. Infrastructure as code is one way we can manage that complexity. Automated testing is another way we can manage it. By building quality in from the start, just like we do with our application code, we can have confidence in our infrastructure at scale and at velocity. When we talk about bringing testing to our infrastructure, it's still important to consider the different types of testing to use, just like we do when we build a test strategy for our application code. This is a variation of the testing pyramid that's been around for years. Tests at the bottom of the pyramid are cheaper and easier to create, and they give us quicker feedback. They're more fine-grained and generally should be testing one thing or a unit. Tests at the top of the pyramid are more expensive to write, to run, and are often more brittle and harder to maintain. In the case of infrastructure testing, tests toward the top of the pyramid are more complex because it involves spinning up resources and tearing down cloud resources. These infrastructure tests also have to test against that infrastructure in the cloud. Manual tests are more expensive, and that's why they're at the very top of the pyramid. We want to have a balance of fast and cheap tests with those tests that are closer to the real infrastructure and production environment and actually reflect reality. Just like when you test your application code, you can do the same for your infrastructure code. Some of the benefits of test-driven development are reduced defect rates, Test-driven development can also improve the overall design. It keeps you focused on requirements, so you only implement what you need and nothing more. It keeps you focused on small parts, so you can make sure that those small parts work. It can also serve as documentation for your team. And finally, it gives you confidence in what you're building so that when you refactor or add new features, you know that what you're building is working. With test-driven development, you can follow the same red-green refactor flow that you do when you write your application code. First, we'll write a failing test. Then we'll write only enough production code to make that test pass. And then we'll refactor it to make it better. Let's talk about the cheap and fast tests, or the unit tests that I mentioned in the testing pyramid. A unit test exercises a small part of your application, 1 unit, and verifies that it's correct. Unit tests are quick and can be run frequently. They can help us get feedback early on so we can shorten the feedback loop. They help us communicate requirements to our team. They can be run in our CI/CD tool. And traditionally, unit tests are isolated from other resources like external APIs and databases. This is done so that we reduce the scope and the number of variables that can affect the results. You can apply the same process to your infrastructure code. We don't need to provision all of our infrastructure or even a little part of it to test that we're configuring it correctly. Now, a unit test against infrastructure checks if a resource will be created with the correct configuration. It checks that the correct number of resources will be created. And it checks if dependencies between resources are correct and if interpolated values are correct. This is an example of a unit test that is testing AWS CDK code. Here we're using the Jest unit testing framework. And on line 10, we're making sure an EC2 instance will be created with the right key pair, and we'll use the correct instance type, a T2 micro. On line 17, we're making sure our stack has an elastic IP resource created with a specific set of tags. Once you have your infrastructure code and it's unit tested, we can apply it to create our resources in the cloud. We could go into the AWS console to check the state of those resources and manually verify they were created correctly. But how do we know it's really correct and what we wanted to create? And how do we do that at scale? If we have many EC2 instances across different regions and maybe even different accounts, we have to manually check each and every one of those. That can be really expensive though, so that's where integration testing comes in. Integration testing is a form of testing where we test the interactions across different units or modules. In the case of infrastructure testing, we're testing across different cloud resources. Integration testing allows you to verify your provisioned cloud resources are created and configured as you expect them to be. As I mentioned earlier, the cloud makes it easier to scale, but it adds complexity. Integration tests can give you the confidence in your infrastructure at scale and at velocity. We can use Chef and Spec, which is an open source framework for testing and auditing your infrastructure. With InSpec, we can execute and write tests with a domain-specific language or a DSL on remote systems like servers, containers, and cloud resources. This can be used on any machine or resource, regardless of whether it's managed by Chef, AWS CloudFormation, the AWS CDK, or even manually by a human. It's easy to read and learn, so it can be used across teams. Teams like security can set their own rules and impact levels, and then tests will fail or pass based on those rules and impacts. This also helps to ensure that requirements are met in every environment at every stage of the software development lifecycle. This is an example of integration testing using the InSpec testing framework. Lines 10 through 13 get the output values from our stack resources, or the IDs. Line 15 makes sure that a specific EC2 instance is running and configured correctly, and it uses the instance ID output value that we retrieved on line 10. On line 21, we use the AWS EC2 instances resource block to test against all EC2 instances that are tagged with environment equal to dev. Then we make sure that they're stopped. We can also use integration tests to detect drift. Drift occurs when cloud resources are changed manually or outside of your infrastructure code. Frameworks like CloudFormation or HashiCorp's Terraform can only detect drift of resources that are managed under that code. This is where a tool like InSpec can help. It's ideal to have all your infrastructure managed in code, but not everybody can do that, and not everybody is at that stage. It can help you detect drift by comparing the desired state, what's in your InSpec test code, and the current state, what's in the cloud. And then it gives you the control of whether you fix the infrastructure in the cloud or the test code. Today, your process might look like this if you're not doing any sort of infrastructure testing. You find your issues in production, or you don't find them and your customers do find the issues. Infrastructure as code plays a key role in CI/CD. It relies on infrastructure automation to create consistent environments. It does this so you can be confident that what you built works in each environment and for your customers in production. When you automate your infrastructure tests, you can also put your infrastructure code through the same CI/CD pipeline. You can iteratively develop, run automated tests, the unit tests and integration tests we just talked about, and deploy your infrastructure through each environment just like you would your application code. By moving our infrastructure testing earlier in the pipeline and doing it at every stage, you'll find bugs earlier in the process when they're cheaper and easier to fix. To end, I want to leave you with 3 pieces of advice. First, treat your infrastructure code as code. You can code review it, version control it, unit test it, integration test it, and push it through the CI/CD pipeline.
1 minute left.
Second, even if you're not testing in production, your customers are. Third, and lastly, the earlier you catch bugs, the easier and the cheaper it's going to be to fix them. Thank you for joining me today. You can find me on Twitter or LinkedIn if you have any questions or feedback. If you're interested in looking at the code for this talk, you can go to the bottom link here and find a GitHub repository with sample code. Thank you.
just you and I. Yet the burn makes you feel so alive. And live in the moment till you don't even tonight. We're here now, let's party together. Let's live like tonight is forever. We're here now, let's party together. Let's live like tonight is forever. Let the rhythm move us, yeah baby, take it too far. You're at the center of my attention, yeah you got me so lost. I love the way that you move.